Alright, so welcome back to another video. So today's video, I'm going to be talking about an upgrade I'm making to our Class B RV. So it's been about a year since we built this custom Ford Transit van conversion. When we built it, we installed a Rec Pro or Hot and Bel Air 9500 BTU unit on the roof. You can see it up there. It's a 120 volt AC powered air conditioner. Again, it's 9,500 BTUs. So the power draw on it is substantial when it comes to a van and running off batteries. It's mainly ideal to run the air conditioner when you have shore power or a generator. It will run off the batteries. The max amount of time I've gotten has been between 6 and 8 hours. So what I'm going to be doing today is testing out a new product. It's made by a company called Countrymod, and it's a 12 volt inverter air conditioner. It does come in 12 or 24 volts, white or black, and it is a 10,000 BTU, so it should be very comparable to the AC air conditioner on the roof. One of my regrets when we built this van was not installing a 12 volt inverter air conditioner when we built it. So now it's going to make it a lot harder because I don't have the heavy gauge 12 volt wiring in place up to the roof air. All right, so again, here is the unit that we currently have in place. So the wiring basically runs out of here, goes down into the wall and back, and then down into the power system. So what I'm going to do before I get too committed is I'm just going to pull this unit out, leave the wiring in place, put the 12 volt inverter unit in place, and then I'm going to do some comparisons between how much power draw and the perceived functionality of the unit, obviously to keep it cool on a warm day here in the van. So we'll start with this unit that's currently in place. I will use the Victron battery monitoring system. We'll start at 100% and we'll run the air conditioner for a predetermined amount of time. Check the energy uses on this. We'll install the 12 volt one. We'll compare them. And if the inverter air conditioner is as good as everyone says it is, we'll find a way to permanently mount it. So again, this air conditioner is from a company called Countrymod. I think they're a little newer in the segment, but I think that this air conditioner is very similar to the V-Lit unit that's getting pretty popular on the market. You can see it's a decent size footprint in the box here. So this one is wider than the one that's currently on the roof, but it is probably a little bit shorter lengthwise. So I went with the black. Again, these come in 12 and 24 volts, white or black. So the overall dimensions of the 10,000 BTU unit here is 31.7 inches by 31.7 inches by 7.5 inches tall. So it's not very tall, which is really nice for your overall clearance on your van. It does fit a standard 14 by 14 square, which is like what all of our Max Air fans and any other RV AC uses. Total weight is 54 pounds. So there's a temperature range of 61 degrees Fahrenheit to 86 degrees Fahrenheit, which is 16 Celsius to 30. Again, they say the current range is 40 to 60 amps on 12 volts, 20 to 30 amps if you do the 24 volt model. So I'd say the big advantage to this unit over pretty much anything else on the market right now is this is under $1,000 for this unit. So much more cost effective than most of the other inverter units for sure, and significantly cheaper than like the one that I'm potentially replacing. All right, so in the box we have obviously the unit itself. Here's our mounting plates, like a remote control and the manual, and we'll talk more about that in a little bit. Has a separate control panel. It gets mounted on the unit, so it's really nice. You can reach up and control everything on this unit and not just use the remote, which you couldn't do on my other one. Some vents. Here's, give you a pretty good size set of cables for it here. These look like 6 gauge possibly. All right, so real quick, before I get started on removing the old one, the draw to this, the bonus supposedly with these lower volt compressor style. They're kind of like a mini split in your house in that the compressor can run at variable speeds. So normally with like the units on there now, I do have a soft start installed in it, but when it kicks on, the compressor just runs. It just turns on and pumps Freon. And then the fan kicks on and you can control the fan speed, but then it just runs that compressor full out until it's ready to turn off, then it cuts off. So it's kicking on and off, shaking the van. This one can vary the speed of the compressor, ramp it up and down depending on the demand. It's also much quieter. So supposedly sound level that comes out of this is supposed to be a lot quieter than a traditional AC rooftop unit. It's supposed to run at about 55 decibels at its loudest. All right, so for our first test, we're looking at the Houghton Bel Air. This is the 9500 BTU AC that runs on 120 volts. So obviously it has to run on an inverter or shore power. So let's see. We have our batteries charged to 100%. In fact, we're floating right now. You can see the system is not using anything and not putting anything into the batteries. I'm going to go back in the back and turn the solar off. And we're just going to basically shut down everything except I have to have the 12 volt system running for this unit here. And so it'll just be the security cameras in this unit pulling power, and then we'll establish what that baseline is. All right, so we have no way for power to go into the system. Obviously the cabin lights are on in here. If I turn those off, it drops our load to about 2 amps. So we're pulling 2 amps just to run security in this here. So now I'm going to turn on the inverter and we'll look at just the inverter and standby. So you can see it went up about 2.6 amps. The batteries are outputting around 3 amps. Actually, what I think I'm going to do is I'm just going to go ahead and set it to as cold as it will go, which I believe on both units is 62 degrees. So if I turn it on, actually it looks like it's 60 degrees on here, so I'm going to pop it up to 62. So this does have a soft start installed, which does help tremendously, and the company now sells them with soft starts that you can get installed before you buy it. I put it in. There's another video on that. So you can see right now we're pulling 8 amps off the batteries. The compressor is not kicked in yet. All right, so I hear the compressor starting. You see it's ramping up here. 18 amps. There it goes full. 45, 63, 64. All right, so I'm allowing the air conditioner to run in auto cool mode. So I don't have the fan speed set to a certain speed. It will run maximum wide open to maintain the temperature that it needs here in the van. So we're settling down to about 61 amps. So obviously while this is running, the compressor will turn on and off. So when the compressor turns off, the power usage goes way down and our remaining time will go way up. So this isn't exactly accurate. That's assuming that the load was constant. So if you were in extreme heat where the air conditioner was never able to cycle off, if you're out in the desert or something, this may be accurate, but in our case, it's going to cycle on and off, set at 62 degrees. So we'll give this a couple hours, like I said, come back, we'll see where it's at, but those are our numbers so far. Looks like we're up to about 70 amps now. All right, so here we are. It's been almost 2 hours now. Let's get a few more minutes. Outside temperature is 82 degrees. Inside temperature, wait for it to update here. It says 72.9, even though the set point is 62. Actually feels cooler than 72. That's measured by that sensor back there. So we're pulling 85 amps off the batteries right now. So it has gone up a little bit. That's right around 1,000 watts, 1,100 watts, and down to 71%. It says remaining time 2 hours and 33 minutes at this rate. All right, so I was waiting for the compressor to kick back on. So it's been 2 hours and 1 minute. Again, just kick back in full speed, pulling around 85 amps. Again, total load off the battery, the AC load, which is the actual power that just the AC unit is using, 856 watts or 8 amps at 120 volts. All right, now we've got our figures. It's time to move on to the new 12-volt inverter air conditioner. Right, so we're back in here. I have it temporarily in place here. Got our batteries 100%. Everything's turned off. Outside temperature again, 81 degrees right now. So same setup. I'm gonna go ahead and turn it on. So the first thing I had to do, I switched it to Fahrenheit by pressing the mode and the down arrow while the control was off. I switched it from Celsius to Fahrenheit, so if you need to do that, I'm gonna just turn it on. So you set it by just arrows. Alright, so initially, the compressor hasn't really kicked in, it's just hardly pulling anything. You can see it ramping up. So it kind of slowly ramps up to 24 amps here. 3 of those are the DC system. So it does have motors that control opening and closing of these dampers here. So that's running on high. It is cold air coming out of it. Obviously I don't have this secured properly, so the cold air is not necessarily coming out of the right spots, but it is coming out. Alright, so it's kind of settled into just about 24, 23 amps. So if we subtract the system, right about 20 amps that it's pulling right now, which is nice. So if I, again, it's not really fair because I don't have this hooked to the ceiling right, but see the air coming out. It's in the 30s. It's about 36 degrees, 32, 31. Alright, so here's what it sounds like running up on the roof. Is significantly quieter than the other model, even outside. So we're going to give it the same time. So we'll say it's 4:55 basically when we started, around there, 4:56, and we'll come back in 2 hours and we'll check our battery percentage. Shut it down. It is 6:56. It's been running 2 hours. You see it. When it shuts down, it closes these louvers. Alright, so we're down to 89%. So that's a huge difference. Average running amperage was around 20 to 30 amps. 30 amps at the highest. The compressor did seem to rev up and down a lot outside, but you couldn't hear any of that inside here. The fan speed was pretty constant. Just kind of depends on how you have it set. If you have it set to auto, or you can set the fan speed where you want. There's 3 basic modes. There's just cooling, there's turbo, and there's the eco mode. And basically just regular cooling is what you'd have it in most of the time. At night you can put on eco mode and it'll use less power. It'll just lower the speed of the compressor outside. And turbo mode runs the compressor at max. So I know this says heat on it. Some of these can come with a heat pump. I don't think this one, I believe it does not have heat, so it's just a universal remote. But that was a big difference. So last time, if you remember, we used 30% of our battery to run it for 2 hours. This time we used 11%. So huge difference, and it just went down from 90 to 89. It says 76 in here. It is cooler than that. I can tell just by feel. I'm not sure if this towel I had here was blocking the sensor a little bit, but it feels good in here. It feels cool. This thing was cycling on and off. I noticed that this is the temperature probe for this unit. Obviously this is installed correctly. This would be in the return air, but kind of like my last unit, I'll have to play whether I want to leave this kind of exposed out here out of the return air, because it allows the thing to cool more. So we'll figure that out. But now that I've done the test, we can see the results. I'm definitely gonna put this one in. I like how it works. It's real quiet. All right, so as far as actually installing the new 12-volt unit permanently, after I got the old mounting gasket off the roof and everything cleaned back up to my 14 by 14 inch hole, I took the supplied foam gasket and I used Sika sealant and applied it per the instructions, gluing the gasket and then building up a rib of sealant around it to prevent any water intrusion. Then I placed the rooftop unit on top, got it approximately lined up, and you can do the rest from inside. Inside you can see there's threaded rod that gets threaded in 4 locations. I then marked and cut them. They were too long. They do give you short ones and long ones. The short ones were too short and long ones were way too long, and cut those a little bit shorter. I then applied blue Loctite to the threads before I installed them. After installing them, you use this metal plate right here, and that's what actually goes on here. And then the supplied lock nuts were slowly tightened down to kind of clamp the whole thing together. You just kind of have to use your best judgment on when to stop tightening it, but you obviously want to compress this foam gasket enough that it won't leak. So after I get this all screwed, bolted down, obviously you can see I got my wires run. We had to get creative. Again, we did not, plan this. So we had our, 120 volt wire in here, which I capped off and I disconnected from power distribution center. And this was an extra wire we had for a thermostat for future use. So that's all just tucked in. Drilled this new hole here, got our included cables run. The only place where it got tricky was we went back here, we took the fridge out and ran everything behind in the power center. But there's a rib that we had to get over right here. There was no way to get through going through the roof. So in the shower here, you can see the cables come down and they go back up. And what we're gonna do is build, a cove that basically covers that area. You'll never even know that we had to do that. So now we've got all the wiring in place. I made the wiring connections in the back. I just used an 80 amp circuit breaker coming directly off of our 12 volt power distribution system to provide our constant 12 volt battery power to that, depending on whether you get 12 or 24 volt system. Obviously, depending on which unit and the system voltage of your van. We've got these other wires that come down now. So in prepping this cover, you see I need to put a few more screws in, but they give you these screws. You want to screw this piece onto here. You'll see that there's like multiple different mounting holes that only really screw on one way. Just like you want to screw the part with the foam, you'll see where it lines up, and you screw that up to this part here with the self-tapping screws. And then that's what gives you your, adjustment for the depth of your ceiling as this slides over that. Once we get this slid over, we'll secure to the wood, the roof, with 4 screws, and then the final trim piece will go over top of this. We'll get all the wiring pushed through, and obviously our control panel will get all plugged in. All right, I've got all the wires pulled through the middle. I got this last piece with the 4 screws in. The last panel that goes in is this cold air return screen. It's kind of deceiving because there's screw holes, but there's no holes in the front. I think you just have to make those holes. Well, as you screw it in, it'll make the holes. So this little sensor here, you want to put in the cold air return. You do have 2 screws that are flat on one end. Alright, so there is the finished product. You see we've got some touch-up work to do where the old unit was. Once you switch on power, again, so the vents make a little noise when they open. Alright, so we definitely weren't being fair on that initial test just because the air wasn't able to get out both sides like it is now. It's already cold and it's just blowing out the front and the back, and this is just cold air here. You can stop them if you want them in a certain position, or you can just allow them to keep oscillating like that, which blows cold air up and down, front and back. So one last energy consumption look here. It's 85 degrees outside, right in the sun, pulling 40 amps right now. This is the highest I've seen it. It is in turbo mode. And again, that's with about 3 amps draw from the lighting. So almost 40 amps, about 30 some. And then you can see it ramps down pretty quick. I put it in eco mode. It's the little green symbol there. Basically, there's eco, auto, and turbo. You can see the difference. We just kind of ramp down and up. It's around 10 amps to 20 amps, just depending. So yeah, it's a lot more energy efficient. That pretty much sums it up. It's a lot more energy efficient at the same BTU rating than the 120 volt AC unit that we replaced. Highly recommend. Obviously, time will tell, but so far, I really like this unit. All right, so I will have a link in the description where we got this. You can just buy it on Amazon, and that's how I recommend you get it. The manufacturer claims, like I said, it's made in the same factory as another real popular one, so you take that for what it's worth. As always, thanks for watching. If you have any questions, be sure to leave them in the comment section below. Please subscribe, like the video. Until next time, we'll see you later.